Hi there, this is Penelope. This is a video for DE4102. This is topic 8 for class 1. And what we're looking here is at some new techniques. Now, what we've done is we've already looked at how we differentiate something like that, H. We've already looked at how to do that, but now what we're looking at is something where we've got a product, and it has to be that both things are functions of x. Now, what I want you to do is I need you to set out every single question in the same way. So let's start with the first one. Y equals x squared sine x. What I need you to do is I need you to name the first function x squared. I need you to name the second function v, just so we're matching this sort of thing. Then we need to find u dash and v dash, and now all we have to do is use the rule that says that dy by dx is u dash v. So u dash v is 2x times sine x plus u v dash. Now, you can leave it like that. In this course, you don't have to simplify, though of course you can. So that is the setting out. Let's squeeze in the third one down here. U is equal to the first function. V is equal to the second function. So u dash is 1, v dash is 1 over x. So dy by dx is equal to 1 times natural log x plus x times 1 over x. Now, obviously there you can simplify that, and then that becomes natural log x plus 1. Okay, so that level of simplification is really needed. Now the next one, u equals e to the 2x, and v we name as cos x, or cos x we name as v. U dash is 2e to the 2x, and v dash is negative sine x. Dy by dx then is 2e to the 2x times cos x minus e to the 2x sine x, just by following the formula. So I want to see everybody setting out exactly the same. Once we've done the differentiation, then we can do exactly what we've done before, where we need to find the gradient at a particular point. But the only difference now is that what we're differentiating is a product. It's a function times another function. So let's call the first function u, let's call the second function v, then u dash is 4x and v dash is negative e to the negative x. Dy by dx is 4x, so it's u dash times v, so it's 4x times e to the negative x. Now, I'm just looking a bit ahead here. I can see that v dash is negative, so I'm going to write the negative sign in there. 2x squared e to the negative x. We're asked, now we need to finish the question, we're asked to find that when x is equal to 1. So all we have to do is pop 1 into our calculators in that function, and we get that it's approximately equal to 0.736, which will tell us that the slope of that curve is 0.736 when x is equal to 1. Look at these problems. These problems are asking you to find the derivative or find the derivative at a particular point, but these are not products in the sense that we've just been looking at. These are just standard functions. They are not products. So A is not a product. B is not a product. This is not a product. This is not a product. So we don't need to use the product rule. We can just differentiate as before. Let's have a look at the first one. If we forget this, then it doesn't matter. It's better to use the product rule unnecessarily than not use it at all. So let's say u equals 5, v equals e to the 3x. Now the derivative of u is 0, the derivative of v is 3e to the 3x. So now, using the product rule, we can say 0 times e to the 3x, which is 0, plus 5 times 3 times e to the 3x. So that gives us 15e to the 3x. Now, if we'd just done it using the rule, then we could have gone straight there and said that the answer was 3 times 5 times e to the 3x, which is the same as before. So it doesn't matter if you use the product rule unnecessarily. What does matter is if you don't use it when you should. Now, all of these problems here, all of these, you need to use the product rule. Do not, and this is what students do all the time, do not just multiply the derivatives together. That's wrong. Okay, that's wrong. Let's put that there. That's wrong. Alright? That's wrong. What we need to do is we need to use the product rule. So in each of these, you need to isolate what is u and what is v, because we have a function of x times another function of x, a function of t, oops, that should say t, times another function, it should also say t, a function times a function. Now here, all we've got to recognize is that if that's called, say, y, and it's if y is equal to u v z, say, or u v w, then the derivative is going to be u dash v w plus u v dash w plus u v w dash. And you can go on forever. You can have 5 functions multiplied together to use the product rule, just like that. But you must use it if you've got functions of x or t or some other variable multiplied together.